Greetings, everybody. Jesse Moran here with Screw Conveyor Corporation. In today's presentation, we're going to be talking about drag conveyors. And in particular, I'm going to talk about our Superflow drag line, which is our most popular one. We'll also discuss our other drags, which are flat bottoms. But for the most part in our presentation, what I'll discuss is every part of that Superflow, including the internals. So with that said, let's get this presentation going. Now on the next part of this presentation, what I'm going to be showing you guys is our catalog and the different designs of drag conveyors that we have, as well as capacities and some information in regards to layouts. What I want to show you guys is our drag conveyor catalog, and if we go over to screwconveyor.com, what we want to do is go over to Download Center. Go to catalogs, and over to the left is drag conveyors. Download that. And this is our drag conveyor catalog. And for the most part, I'll get over to the design aspect of the conveyors in a little bit. But what I do want to show you guys is I want to start off with the Superflow drag conveyor and show you what sizes those conveyors range in, and as well as capacities. So for that, we're going to go to page 7, and if you notice, we have 6-inch drag conveyors all the way down to 24-inch, and our capacities will range anywhere from 1,080 to 25,760. Now, this 25,760 range is at 175 feet per minute, so you might want to be careful with the speeds on that one, and it all depends on the capacities as well. Another chart I want to show you guys is the horsepower chart. Now, if you have a project that you're looking to see or looking to get, and you want to get an idea of horsepower, and again, you have to remember that these charts are for materials that are free flowing and roughly about 48 pounds a cubic feet. So, for instance, in this 6-inch column here and row, if you go down 100 feet per minute or 125 and so on, you can see a 0.014 for horsepower. So what this does is it allows you to multiply this number times the length of your conveyor, and it'll give you a horsepower. Now you want to mark it up obviously to the nearest horsepower that's available in motor, but for the most part it gives you an idea of what the horsepower usage is for that capacity. And again, you have to understand that you have to remember this is for a free-flowing perfect world 48 pounds a cubic foot. It'll give you a good idea of what you need to do and use to give you horsepower in case you need to get wiring or whatever the case may be for your project. Another part of this catalog is you can see conveyor weights. Now these are empty weights, and you can actually get your weights based off the drive terminal, the contour tail terminal, the divided flow inlet, and our trough sections. And of course there's gauges, but it'll give you weights per gauge. For the most part, our Superflow XL, which is a little bit heavier duty than our Superflow drag conveyor, and these conveyors also range in sizes. And if we get down to page number 11, we can see that our conveyors range from 12-inch to 30-inch. And again, this is a conveyor size, width and depth, and the depth for most of them is 22 inches. So, and the capacities for that is 68 cubic feet an hour, and that's at 12-inch, and it goes all the way down or all the way up to 36,420. Now again, that's for the 30-inch, and that's 250 feet per minute. So you might want to be careful with those ranges as well. It also covers conveyor weights in this area. So if you want to get some weights in regards to the conveyor due to a project, you can do that. Unfortunately, we don't have a horsepower factor or page that you can reference for our Superflow Excel, but if you want to get to know the Superflow Excel and need horsepower, then for that you'd have to give us a call. And now if we continue on, we can get to our EnduroFlow, and in our EnduroFlow sizes range from 24 inch again to 30 inch. Our EnduroFlow drag conveyor is designed for a heavier aspect, heavier application. It handles much more load. It can receive much more material. And if we continue on down to page 15, we can see the capacities, which is 24 inch at 160 cubic feet an hour. Now that's at one chain speed in feet per minute, and that's one at 160, and we can go all the way to 250 feet per minute. So for the most part, 24 inch, 160 minimum, and you can go with 30 inch, and that'll take you to 50,000 cubic feet an hour. Now remember, this is a capacity and chart based on perfect world, certain capacities per cubic feet in material, so you want to be careful with that. Another thing to think about is inclines. Anywhere, if you want to go much more incline, then there's different factors for that. There's going to be factors for horsepower and obviously for speeds because of the incline. And then things to think about is your flight attachments. Standardized attachments every 6 will operate for horizontal purposes. If you want to get into heavier inclines, then you're going to have to go with the 4th link. And this goes for all 3 conveyors. So, but for the most part, EnduroFlow weight charts are also available in this page 15, and you can get to that at that point. And this is just the introduction of the drag conveyors that we offer. And again, you can find these on screwconveyor.com at our download center, and just download our app. Now, why a drag conveyor? Drag conveyors consist of evenly spaced rounded or rectangular flights mounted on a continuous chain that travels around a drive and tail sprocket. The chain and flights are housed in a trough assembly that consists of materials conveying section and a return section. Drag conveyors typically operate with materials being control fed into the trough area, but can be designed to convey materials in applications where the material is choke fed, so if it's coming out of a hopper. Now, what applications and environmental conditions call for the use of drag conveyors? When conveying capacities for a screw conveyor reach their peak, plus 18,000 cubic feet an hour. When gentle handling of the material is required, material is pulling along, not tumbling or agitating. When trough cleanout is required, round bottom drags are used. When conveying lengths go beyond 100 feet, drag conveyors are typically more economical and can reach lengths in excess of 200 feet. When the material travel path is not on a straight inline over the length of the conveyor, drag conveyors can start off conveying horizontally, then transition up an incline, all in one unit. Drag conveyors can accommodate and convey larger particle sizes versus space limitations found between screw conveyor flights. Drag conveyors offer dust containment and the ability to keep the conveyed product free from the atmospheric contamination. Drag conveyors offer multiple inlets and discharge points if required. Drag conveyors can be manufactured from mild steel, abrasion resistant, or stainless steel construction, and can operate in lower or high temperature applications. Now for this part of the next presentation, what I'm going to be showing you guys is different components in regards to the Superflow, and that would be from tail terminal to drive terminal. So with that, let's continue on with this presentation. This is our contour tail terminal, and what it does is it basically is just like it sounds. It's a contour tail terminal so that the flights can wrap around the sprocket here, go around the contour and down, and take the material weight onto the discharge. Now with this contour tail terminal, it does have 2 bearings on each side, along with, now this is a newer version, but along with 2 seals to prevent any dust contamination getting into the bearings. This is a newer design that we're continuing to go with, but for the most part, This is our contour tail terminal, and I'll show you a little bit more on the sides of this conveyor. Now here's a closer look at this side of the contour tail terminal, and this is just a regular ball bearing on a 1-inch shaft, and that's standardized for this 6-inch drive terminal, but that consists of two sides, so two 4-bolt flange bearings, 1-inch. Now this is our bypass inlet, and what I want to show you guys is kind of what the inside looks like, and this is where the material would come down off the sides, and then the flights will take it away. Here's a closer look at that bypass inlet, and if you notice this doghouse, it allows for the material to seep over to the sides and down to the bottom of the bypass. Now our superflow chain comes in C55, C188, as well as C131 chain. And what I'm showing you here is I just wanted to show you how it goes around the drive terminal sprocket, as well as the idler assembly here. And again, this is a basic layout for our superflow. Now this is our standard components for our superflow conveyors. Consist of a idler assembly, and we have our paddles. And again, each one of these components can be done by a molded plastic or a UHMW plastic. As far as conveyors from 12 and up, you're going to have UHMW. 6 and 9-inch has the capabilities of having either option. So for that said, this is your idler assembly, and it's consisting of a shaft, some cotter pins, and then the attachment bolts to the trough. This is a basic setup for a superflow drive.
So this is the superflow drive terminal, and if you can't get to the trough section in order to get your inside dimension, you can always take the cover off this drive terminal and get that dimension. So what you want to do is get an inside measurement, and what you come up with is 7 inches, and this there is a 6-inch superflow drag terminal.
How do we know that?
What we want to do is go to screwconveyor.com. We want to go to Download Center. We want to go down to our superflow drag conveyor or drag conveyor catalog. We want to go down to page number 7, I believe it is. And what we want to find is the L dimension. And the L dimension gives us the opening of that drive terminal that we just took, which was 7 inches. We'll go to our chart. 7 inches will give us a 6-inch superflow drag conveyor. So as you can see, every superflow size, whether it's a 6, 9, 12, 14, and so on, a 6-inch will have a 7-inch opening, 9-inch will have a 10-inch opening, 12-inch will have a 13, and so on. So if you ever want to know the conveyor size that you need, take off the lids, open that dimension, get that dimension, which was 7 in our case, and we got our superflow size, which is a 6-inch. Now another thing to look for is to make sure we have the drive shaft correctly. So what we want to do is we want to get the projection, 9 inches. We want to get the diameter of the shaft, which gives us 1 3/16. We also want the keyway length, which is about 8.5, and also the keyway width, which gives me about 1/4 inch. Now this drive terminal consists of 2 bearings with the take-up, and these bearings are basically a 2 4-bolt flange bearing, 1 3/16, and there's one on each side. And of course you have your take-up for adjustments.
Now as far as superflow troughs go, they are stocked in 10-foot lengths, and each 10-foot length has 4 idler return shafts. And as you can see in this video, the idler returns are mounted inside the troughs, the visual aspect of it. But for every 10-foot trough, there's going to be 4 idler assemblies, and this goes for any size. Now this concludes our presentation on drags and superflow. Now there's a whole lot more to drags and superflows than what I gave you in this presentation. So if you have any more questions or any questions in regards to a drag or a superflow, come and see me later on. But for the most part, this presentation is done. I want to thank you for your time,
And if you guys have any questions, I'll be taking some in a bit.